And we know that our triangles are always right triangles in this section. So we're going to draw a nice little right triangle. We're going to read the problem, label the sides. Then we'll set up an equation using sine, cosine, or tangent. And we'll be ready to go. So here we go. Here's my triangle. All right, so this is number 13 on practice test 2. Draw a picture. Okay, got it. A squirrel is sitting in the top of a tree looking at a nut on the ground that is 52 feet away from him. So stop right there. Literally read the problem. Where does the 52 go? Hypotenuse. The nut is 52 feet from the squirrel. His angle of depression is 17.7. Find the height of the tree. Always mark the X in the picture too, because that helps you determine which function to use. It's going to be a sine problem. Everybody get that? Sine 17.7 equals X over 52. Opposite over hypotenuse. Multiply by 52. Very good. And then we just type it in. So 52 sine 17.7. I think the tree, what am I supposed to round to? 100? I think the tree is 15.81 feet. Everybody still with us?
Yeah.
All right. A fish in the water 100 feet from shore. Okay, so there's a fish out here in the water 100 feet from shore. Where do I put the 100?
Below.
Right here. Here's shore. This is going to be a lighthouse or something. No, it's a jetty. There's a seagull on a jetty that's 12 feet tall. A jetty is like an artificial, yeah, it's like a bank. They build it out to break the waves so that the boats have an easier passage through. So if this is the ocean shore, you have these waves crashing in. So they build these things out like this, so that the boats come in here, and because these things have broken the waves, it's calmer water in there. Okay, so anyway, there's a seagull on the jetty, there's a fish. What is the fish's angle of elevation to the gull? Now, as soon as I put that X there, I know that when I type this in my calculator, I'm going to be using a second button, because this equation is going to say tan X equals 12 over 100. Which means X is going to be second tan, 12 over 100. So second tan, 12 divided by 100. That angle is 6.84 degrees. Magnus, you okay? All right, an airplane is approaching the airport. So here's the plane. Here's the airport. Find the desired angle of descent if the pilot wants to land at a point that is currently 7,000 feet from the plane. Hypotenuse. And the plane is 235 feet above the ground. This looks like a sine, absolutely. So we're going to say sine x equals 235 over 7,000. How will I type that into my calculator? Second sine. And the answer is, did you get 1.92? Yep, degrees. Find the height of a flagpole. It makes a shadow 16.62 feet long, right there. Where's the 16.62? On the ground, right here. That's where shadows are. They're on the ground. And the angle of elevation is 64. Sine, cosine, or tangent? Tangent 64 equals x over 16.62. Nothing fancy about this one, right? We're going to multiply by 16.62. So 16.62 tan 64 34.08. And is that feet? I can't remember. Yep. And finally E. What is the angle of elevation of a man looking at the top of a building that is 48 feet tall if he is standing 3,000 feet from the top of the building? Where does the 3,000 go? Hypotenuse. Sine, cosine, or tangent?
Sine.
Sine x equals 48 over 3,000. Uh-oh, how do I get x? Second sine. 48 over 3,000. Oh my goodness, I got 0.92. Did I type that in right? All right, what?
So look at that,
We just finished another one, yep. One more to go. So you guys still have another review day. You're always ahead of everybody, so we won't finish this one today, but we'll finish it next time and then do some random assorted review, whatever kind you want to do, whatever problems you want to do, okay, to get ready for Thursday. All right, so here we go. Put the calculators away. Now, because there's different versions of the test, not everybody's questions are going to be in exactly the same order, but everybody is going to have one. Everything that's on the practice test is on the test. They just may be shuffled around because I have to have different versions of the test. Okay? So, everybody's going to have a question somewhere on the test, on the first page, that says change into degrees. So, how do we change this into degrees?
Pi was 180.
We say pi is 180, so 2 times 180 over 5. Now you can either do multiply and then divide. I like to divide first.
36.
So that's 36 times 2, so that'd be 72 degrees. However you do it is fine. Remember, you won't have a calculator though, so you might have to do some figuring over here to the side. I promise it's not going to be anything wacky like, 2 pi over 13 or something weird. It's going to be something that you can multiply and divide relatively easily. All right, now we're going to change into radians. How do we change 100 degrees into radians?
Once you go to like second apps.
This is a no calculator problem.
It's pi equals 180.
We start with pi equals 180.
And then x equals 100.
And then x is 100. Right? And then we'll cross multiply, so 180x equals 100 pi. So you cancel the zeros. Now I got 10 over 18, 5 pi over 9. So your answer is 5 pi over 9. Now, like I said, we're going to have some extra time next time, so as we're going through review problems, put a check mark or something next to the ones you want extra practice on. All right, number 3. Find the measure of the arc. Okay, the minute I read those words, I envision this scenario. And I think of what formula?
Radians equals radius.
Well, arc length equals radius times radians. Okay, so what do we know? We got an angle that's 125 degrees. That's a problem, right? It's a problem. And a radius that's 6. Okay, so that's good. But in order to find that arc length, I'm going to need that angle in radians. So I'm going to do what I just did. Pi is 180. So what is 125? So 180x equals 125 pi. Just cross multiply. Divide. So x equals, okay, 5 goes into both of those, so I'll need to do a little arithmetic. So 5 goes into 125, 25 times. And 5 goes into 180, I think I just did that, 36 times. So the radian measure of the angle is 25 pi over 36, which means that's what goes here. So I have 6 over 1 times 25 pi over 36. Now, you can multiply straight across, or you can notice you got a little canceling going on here. If you multiply straight across, you get 150 pi over 36, which you're going to reduce. See, 2 goes into both of those. 3 goes into both of those. And that's the answer to the problem. It's centimeters. If you cross-canceled at this point, you would get the same answer, 25 pi over 6. Okay, what are the need to knows there? Arc length equals radius times radians. Right? All right. Number 4. We need sine, cosine, tangent, cosecant, secant, and tangent. And what are we told? Well, we're told the cosine's 2/3, which means the secant's 3/2. And what does this mean?
No, it would be
It's
fourth
the
quadrant.
It's in the fourth quadrant. Remember, we're back to normal math. This isn't a compass. So our normal math labels are these. So between 270 and 360 would put us in this quadrant. So what does this tell me? It tells me where to draw my picture. This tells me where to draw my picture. Now I know the cosine is 2/3. Okay? So I marked adjacent as 2 and hypotenuse is 3. Now what do I do?
2 squared.
Pythagorean theorem, right? So 2 squared plus y squared is 3 squared. Did you get root 5?
Yep.
But it's actually going to be
Negative.
negative
Yep.
because of its location. Now we fill in the rest of them. Here we go. What's the sign?
Come on, Evan.
Guys. Your angles at the origin. Opposite over hypotenuse. Negative root 5 over 3. So cosecant is negative 3 over root 5. Remember when you rationalize, the radical comes up and the 5 turns into a plain 5 on the bottom. What's my tangent? Negative root 5 over 2. So your cotangent is 2 over negative root 5, or negative 2 root 5 over 5. Two mistakes people make there if they're not paying attention. First of all, they do the Pythagorean theorem wrong. We don't always just square the two numbers that we're given and add them up, right? You gotta have this one by itself. So it's not 2 squared plus 3 squared. It's 2 squared plus y squared equals 3 squared. What do you think the other mistake is that's made all the time?
Negative.
Forget the negative. Now look, if you forget the negative, you're gonna miss points here, 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 and here, right? Don't forget the negative. What have I told you about negatives? If you're not in quadrant 1, something's gonna be negative. Okay, number 5, find the exact value. This is one that on the actual test, next to it, it will say 2 answers. So this problem has 2 answers. Okay? 2 answers. Magnus, put your head up, sunshine. What is the first thing I have to think about before when I go to start this problem? What's the first thing I think about? Where am I going to draw my triangles? I'm going to get 2 answers, but I have no idea where to look for those answers. So I'm going to stop and think about this for a second. The tangent is a positive number. Somebody said quadrant 1. And you are always good in quadrant 1 if it's positive, right? Positives happen in quadrant 1. Where else would I draw a picture so that when I put opposite over adjacent, I would get a positive number? 3. What happens in quadrant 3, kids? They're both negative. You have to simply stop and think. You gotta think. Now, as soon as I put the 1 and the 1 there, you should think that about that angle. How big is that angle?
45.
That's a 45. And so is this one. They always match. You're never going to have two different triangles. They're always going to be the same. And the hypotenuses here are the actual angles. So that is your actual angle, and it is 45 degrees. So one of your answers is 45 degrees. We like quadrant 1. This is your second angle. What'd you say, Matthew? Yep, 180 plus 45, which is 225. So the two answers to the problem are 45 and 225. Think about drawing that purple angle. You go all the way to here, which is 180, and then you go an extra 45 degrees. The test will only have one of these on it, but here's another one to practice. So this one also has two answers. The first thing you have to do is figure out where you're going to draw. Now, because it's a negative, you will not draw it in quadrant 1. Right? So where will I draw it?
2.
2?
4.
I like 2.
2 and 3.
2 and 3. Now, Ferris, why did you say to draw this in 2 and 3? You are exactly right.
Oh.
Exactly. He's thinking about cosine. Cosine is adjacent over hypotenuse, or x over r. This is the adjacent side. This is the x side. You need it to be negative. This is where x is negative. So he drew a triangle. He said this is negative root 3 and this is 2. So that would be 1. How big is this angle? 30. And so is this one. So now I got to figure out what the actual angles are. So I'm coming over here. Yes, Ferris, you're exactly right. That blue angle is 180 minus 30, or 150. The purple angle is 180 plus 30, which is 210. Remember, your angles are the hypotenuses. So you need to go around the circle till you get to the hypotenuse. Everybody up with us? Caught up? Tangent 3 pi over 2. How do you start this one?
You put the
Change it 2 degrees, so that's going to be the tangent of 270. Oh my goodness gracious. Why am I drawing a circle? Because 270 is on the straight line, he said. 270 is a quadrantal angle. It's on an axis. You're not going to draw it like this. You can't draw it like this. It's on the axis. So when we're on the axis, we need to figure out our x, y, and our r. We really don't have to figure out our r. Our r is 1. What's our x and our y?
The y is going to be also
0, negative 1. So x is 0 and y is negative 1. We want tangent, which is y over x. So negative 1 over 0. Somebody said undefined, and that person was right. The tangent of 270 is undefined. 5 pi over 6. Do we start the same way? Yeah, change that into degrees, so that'd be 150. Anybody have a question about that? Did I do that too fast? James Wayne, your head's rolling around back there. What's going on?
I'm thinking that.
Okay. What is the fascination with that? What is it?
What? This?
Yeah.
Kombucha?
Kombucha?
It smells like vinegar.
Well, why do we have it back there? Put the lid on it.
It's for red too.
Okay, there we go.
There you go.
Okay, so now we're going to draw 150. Now, 150 is not on my line. 150 is over here, right? This is 150. So I can actually make a triangle. Marita, how big would that angle right there be? Yeah, it would be. Don't ask like that. You got it. It's 30. If that's 150 and that's 180, that's got to be 30. So my sides, what's this side over here, Christina?
1.
Yep. And this one would be, Christina?
3.
Yep. And that one's 2. And actually that root 3 is negative. Now we want the sign. Got everything labeled, so we'll just do sign. So the answer is 1/2. Yep, that's all there is to it. 1/2. We turn the page with great enthusiasm. Cosine 7 pi over 4. Same problem. Here we go. What's the cosine of 7 pi over 4? What's 7 pi over 4, first of all? 315. Who said that? How'd you get it? Yep. Pi divided by, or 180 divided by 4 is 45. And 45 times 7 is 315. This is Word. I can't do that in my head. Fine. Do it over here. We don't get points for doing stuff in our head. Right? So do it right. Write it down. Alright, so where's 315? All the way around here. Would you agree with me?
Yep.
So there's 360. Here's 315. Kaufman, what's that angle right there?
45.
You got it. So Monica, what are the sides of my triangle? Once he told me that's a 45. What's this? 1. Root 2.
Negative 1.
And this one is negative. We want cosine. 1 over root 2. Or root 2 over 2. I know some of you are getting bored, I can't imagine it. But remember, these are guaranteed test questions. We want to make sure we know how to do them. 7 pi over 6.
240.
What?
240.
That might be 210.
180 divided by 6. Which is 30 times 7.
Yeah, it's 210.
Oh, wait, no. Yeah, it's 210.
210. Yep, that's 210.
I know.
So the cosecant of 210 degrees. So here's 180, here's 270, so 210 would be right here. Maya, how big is this angle right here where I'm pointing?
30.
Yep, you're going from 180 to 210, so that's a 30. Audie, what's across from the 30 here? What side? Hold on.
2, 1.
1. 2 goes here and the root 3 goes here. We gotta know that, right? We gotta get those numbers in the right spot. Before I go any farther though, I better pay attention to something. They're both negative, aren't they? Right? Now I want the cosecant. Oh geez, cosecant. Reciprocal of sine. Sine is opposite over hypotenuse, so it's going to be hypotenuse over opposite. So 2 over negative 1, which is negative 2. All right, in which quadrant will the secant be negative? Less than 0 means negative, and the tangent be negative. So we need the secant and the tangent to be negative. And I've already heard the right answer from someone. It is not quadrant 3. It's 4. But here's the process that we're thinking about. Secant, boys and girls, secant is associated with which function? Reciprocal of which function? Cosine. Cosine is x over r. So if the secant is negative, it means x is negative. Uh-oh, it's not quadrant 4. Because if x has to be negative, we're over here, right? Isn't this where x is negative? Over here? But now we need the tangent to also be negative. Now tangent is y over x. What happens if you put y over x here? It's positive, so that's not going to work. What happens if you put y over x here? So your answer is quadrant 2. Your answer is quadrant 2. All right, I'm going to stop there because I want to hand some stuff out to you. So we'll make a note, and that's where we'll pick up tomorrow. Or, yeah, tomorrow, right?